Hello everyone! Today we will be learning about vector addition at 90 degrees. Now, you may be asking yourself, what is vector addition at 90 degrees? Vector addition at 90 degrees occurs when you add two vectors together that are perpendicular to each other, which means that there is a right angle between them. Now to solve, we would add vector A to vector B. To find the solution of vector A plus vector B, one uses the Pythagorean theorem. The Pythagorean theorem is A squared plus B squared equals C squared. From this, we know that vector A squared plus vector B squared equals the solution squared. In this equation, A represents the length of vector A, B represents the length of vector B, and C represents the hypotenuse. To find the direction of the solution, you will need to use the tangent function. To solve for this equation, you will first need to know which angle you are solving for. In this case, theta will represent the angle that we are solving for. To solve for this equation, you must know that the tangent of the angle that you are solving for is equivalent to the length of the side that is opposite from the angle divided by the length of the side that is adjacent to the angle. In this case, the side that is opposite to the angle is side A. The side that is adjacent to this angle is side B. In order to solve for theta, we must rearrange the equation, so it may be easily solved using a calculator. Tan to the negative 1 times side length A divided by side length B equals the angle that we are looking for. For our example problem, Jane participated in a marathon this past spring. For the marathon, Jane ran 2.5 kilometers north. She then ran 3.2 kilometers west in order to reach the finish line. What was Jane's total displacement after she finished running this marathon? From this question, we are given delta D1, which is her first distance, which was 2.5 kilometers north. Also given Jane's second distance, which was 3.2 kilometers west. This question asked us to find Jane's total displacement. Our analysis for this question is that the total displacement would be equivalent to distance 1 plus distance 2. Now, since this is a right angle triangle, and we're using vectors which have direction, we must substitute in delta dt, delta d1, and delta d2 into the Pythagorean theorem. Using the Pythagorean theorem, we will let delta dt equal c, delta d1 equal a, and delta d2 equal b. When we sub in these values, we find that c squared equals 2.5 squared, or delta d1 squared, 2 squared, or delta d2 squared. After squaring those values, we find that a squared equals 6.25, and b squared equals 10.24. Now, 6.25 plus 10.24 equals 16.49. But since the c value is still squared, we're going to need to transfer it over to the other side. By doing this, we can simply find the square root of both sides. The square root of c squared simply equals c. The square root of 16.49 equals 4.060788101. Through taking significant digits into account, we find that the final solution for c is 4.1. Remembering that we substituted in delta d total for c, we know that the total displacement is 4.1 kilometers. Now, taking into account that all vectors need a direction, we must now solve for the direction of the total displacement of this equation. Now, remembering the tangent equation, tan of the angle equals the opposite length over the adjacent length to the angle. Through rearranging this equation, we find that tan to the negative 1 times the opposite length over the adjacent length equals the angle. For this equation, the angle that we are going to use is the one that is opposite from side length A, which is 2.5 kilometers, and is adjacent to side length B, which is 3.2 kilometers. We have now subbed in those values, and after subbing in those values, we can solve for the angle of theta. We have found that theta equals 38 degrees. Now, using the total displacement and the new angle that we found, we can put them together to find our solution. Therefore, Jane's total displacement was 4.1 kilometers and 38 degrees north of west.